Calling Cython functions from Numba jitted code. I know that a Numba jitted function calling another jitted function will recognize this and automatically use a fast C calling convention rather than going through the Python object layer, and therefore avoid the high Python function call overhead. My question is whether the same is true if I call a Cython function from Numba. So let's say I have a Cython module, foo.pix. As well as a standard Python module bar.py. Will Numba recognize foo.foo as a C-callable function automatically, or do I need to tell it manually by, say, setting up a foo wrapper? Edit. Upon further reflection, Cython functions are just standard built-in functions from the view of the Python interpreter. So the question can be made more general. Does Numba optimize calls to built-in functions and methods to bypass the Python calling overhead?
There is a limited set of built-in functions, from both the Python standard library and NumPy, that Numba knows how to translate into native code. This URL. Anything else will not be able to be jittered by Numba in no Python mode, thus resorting to object mode, which is much slower. There is no direct way to pass a Cython function to Numba and have it be recognized in no Python mode. Numba does have hooks for fee. This URL that can be leveraged to call outside C code, that you might be able to rig up to call Cython if you could create a low-level wrapper at the C level. I'm not 100% sure if this is possible though. I wrote about doing this for calling math functions from Numba. This URL. It might be helpful in getting you started if you go that route.
It is possible to use Cython cpdef/cdf functions, but not the def functions, in no Python Numba. Step: cdf/cpdef function must be marked as API in the Cython code. Step: numba.extending.get_Cython_function_address can be used to get the address of the cpdef function. Step: C types can be used to create a function from the address of the cpdef function, which can be used in Numba no Python code. Read on for a more detailed explanation. Even if the built-in functions, py function, the same as Cython's def functions, are written in C, they don't have a signature which could be used by no Python Numba code. For example, the acos function from the math module doesn't have a signature, as one could expect, but its signature is. So basically, in order to call this function, Numba would need to build a Python float from the C float at hand, but this is prohibited by no Python equals true. However, Cython's cpdef functions are a little bit different. It is a small wrapper around a real CDF function, whose arguments are raw C types like double, int and so on. This CDF function could be used by Numba only if its address were known. Cython offers a way to find out the addresses of CDF functions in a portable way. The addresses can be found in the attribute _pix_copy_ of the Cythonized module. However, not all CDF and cpdef functions are exposed in this way, but only ones which are explicitly marked as C API declarations or implicitly by being shared through a pxd file. Once the function foo of the foo module is marked as API, the address of the cpdef function foo can be found in foo module._pix_copy_dictionary. It is surprisingly hard to extract the address from a Py capsule in Python. One possibility is to use ctypes.python API. Another, maybe easier one, is to utilize Cython to access Python C API. Which can be used as. However, Numba offers a similar functionality out of the box, get_Cython_function_address. Once we got the address of the C function, we can construct a ctypes function. This function can be utilized for example as follows from NoPython Numba. And now yields the expected result. Arguments of type functions which are understood by Numba out of the box can be found here in R.
If you want to see more, please consider subscribing.